So, good evening. My name is Paul Lowe. I'm a senior lecturer here at Melbourne School of Design. Welcome to the third public lecture of the AA Visiting School program. Tonight also happened to be our MSDX exhibitions night, the winter exhibitions. So welcome everybody that's also joining us at events platform. Before I begin, I'd like to acknowledge the traditional owner of the land on which this meeting is taking place, which may be multiple lands given the location of all of us. I pay my respect to both past and present and extend that respect to other Indigenous Australians present. So tonight we're delighted to have Daniela MITTERBERGER and Tiziano DERME with us. And they are fairly close, always closely related to the Melbourne School of Design. They have taught here before as studio leaders at the CDE studio level. They were also unit leaders at the AA Visiting School last year at the AA Visiting School Melbourne. And this year, we have invited them back to give us the public lectures on their most recent installations at the Venice Biennale entitled Magic Queen. I will now invite Mon Q, who's the director of the AA Visiting School Melbourne, to introduce both Daniela and Tiziano. Mon?
Thank you, Paul. Good evening, everyone, and good morning to Daniela and Tiziano. It is with great delight that I'm about to welcome you tonight, Daniela MITTERBERGER and Tiziano DERME. Daniela is an architect with a strong interest in new media, the human body, digital fabrication, and emerging technologies. She's currently a researcher at ETH Zurich, focusing on intuition in digital design and robotic fabrication. She's the co-founder and director of MaeiD, and with Tiziano DERME, they create tantalizing, thought-provoking creatures and environments, blurring the lines between body, architecture, biology, and landscape. Which brings me to the other half of MaeiD. But quietly spoken, Tiziano is also an architect, researcher, and media artist interested in the relationship between different medias, materials, and performance. Tiziano is an assistant professor and researcher at University of Innsbruck, focusing on autonomous robot interactions, and as a fellow of the Emergent Media Artists of the EMAP Creative European Program. Tonight, both Daniela and Tiziano will be presenting their most recent project on Magic Queen, which is currently exhibited at the 17th International Architecture Exhibition of the Venice Biennale. The title of this talk is How Much This Creature Weighs, How Many Hours Was Spent, How Much Material Was Used, and How Many People Required to Birth This Queen. So rather than me speaking about it, I'll let you both, Daniela and Tiziano, to delve into the depths of our new relationship with this form of new wilderness. I'll hand it over to you, Daniela and Tiziano.
Thank you very much, Mont. Thanks a lot, Paul, and thanks to Melbourne School of Design for inviting us. We are very happy to be back again. I will start sharing the screen now.
Yeah.
And so Tiziano and I, we are MaeiD. We are Büro für Architektur und Transmediale Kunst, so an office for architecture and transmedia art, which is an interdisciplinary studio, and we founded the studio in 2015 in Vienna. And the aim of the studio is to locate new technologies within novel human-animal machine entanglement. And as a young practice, we love this idea of navigating in the discipline of architecture through different technologies and around projects that are often tangential to architecture, but always situate in space and deal with questions of space. Today, our talk will be a hybrid. That means with one foot in the technical realm and with one in the creation of architecture as a hyperlocal, integrated, fragile ecosystem. Especially, we will introduce the Magic Queen to you, and not just the final Magic Queen, but actually everything that was necessary to lead to the creation of Magic Queen and the whole side stories that you normally don't see when it comes to the final exhibition. MaeiD, maybe to give you a quick overview what we're doing in our office. So as we said, we are working with a lot of different actors. We work with the relationship between human, space, new media, and performativity. And we're striving to establish this relationship with otherness by developing new dynamics of exchange between listeners and receivers, between signals and frequencies. And with our work, we aim to present across media and across scales. So that means the research of our studio covers a wide range of different disciplines, such as biomaterial research. We're covering and working with robotics. We are developing interfaces, working with multimodal cognition, as well as art and science. We understand our work truly as a seamless interaction between computation, the material world, and the virtual world, between living systems and machines.
We really do understand architecture not really as an isolated unit, but something that is rather woven in and woven off its habitat, and at the same time woven off its fabrication setup. So we like to picture this scenario in a way as a continuous interplay between who is observing, who is receiving, who is listening. So in this scenario, of course, tools, devices, and as well computational processes allow us to really bridge those different subjects and media. No? So the act, of course, the act of discussing is a relational one. No? And the act of discussing different subjects is a political one. So the German word Umwelt, in comparison to Umgebung, describe exactly this idea of living in a causal relationship rather than only into a spatial constraint. So perhaps the project that we will present today, perhaps they relate to a very specific domain of intervention, no? which is basically the domain of the relationship between nature and technology. Within this context, we really need to start understanding architectural design within a larger and broader system of relations. No? One that is able to mediate somehow our presence with the things of the world, with the earth, weather, climate, biotic, abiotic systems. So we maybe want to reconnect with reconnect architecture with a new system of reciprocal forces, that require a radical shift in the way we build, manufacture, select, use material, and of course how we discuss those problematics on a technological level, but also on a cultural one. And within this context, of course, help us a lot to think about gardens as a cultural typology, and a typology that is very familiar to us in understanding our relationship to nature. And we believe the theme of the garden is a very architectural one, of course, because it relates to a spatial condition, and is entangled with a very particular context of resources, and the idea that whatever action we do upon a specific territory needs to find a sort of attunement to the environmental context. No, so we do something, we expect things to happen. No, growth, decay, or have a sort of cycle. This typology, of course, comes as well with the potential of mediating what is artificial, what is natural. So in this context, architecture is not really considered as the only medium to shelter our body, but rather as a manifold. As a creation of a support that is able to foster life, is able to host plants, animals, germs, and as well humans. The idea is not really to understand nature and architecture as a romantic as well as a romantic return to what we call Mother Nature, but really to reconstruct our idea of nature through the lenses of current technological paradigms.
coming to this idea of the combination of current technological paradigms in relation to the idea of nature. And if we think and start to think about robotic and autonomous technologies, these technologies enable us to imagine new environments that can actually operate autonomously of human decisions and interventions. Those robotic and autonomous environments possess the technological capacity to fabricate, sense, and gather data, as well on ecological patterns, processes, and provide a fertile ground for a new set of relationship amongst humans, nature, and technology. Placing these machines in the gardens, such as lawn mowers machines or automatic lawn watering systems, enforces a form of control and automation over nature. That means we already place machines into nature, but we actually do this just to control and automate it according to our very clear vision, our timing. In contrast to automation, we find the concept of autonomy, which describes the production of a norm of a rule or a rule. And the resulting autonomy, as we also call the term wildness, or the aim of the wildness provided through technology, describes a territory of self-governance beyond human control. So beyond automation and beyond the desire of humans to control nature. This condition perhaps reflects a possible opening towards a relationship between nature and technology, where machines suddenly enter a new trans-species courtship dance against nature.
So within this context, of course, in the debate of nature and technology, it's interesting for us, as we said, to create it, to embrace into a new set of complex relationships, no? That comes as well from the mediation between us and the environment, no? But as well, it comes with a lot of opportunities in the way how we translate, observe those impulses into a different set of, for example, parameters that could be useful to understand the space of architecture. So we really believe that we need to really develop new practices of observations that are not uniquely based on our visual spectrum, no? And, but rather they entail, for example, a synchronization of different scales at different times, no? And the attunement of our expectations in relation to it. Especially concerning, the word feedback, no? When it comes to biological processes, it's not really mediating our expectations relates to exactly, I don't expect immediately an exchange, no? But rather I accept a different temporalities, no? And this is something we kind of, we are really interested in.
The Magic Queen and the resulting Artificial Ecologies series is, of course, not born in a vacuum. Different projects inspired the research and thought processes of the Magic Queen. We very much believe that innovation, as I said, does not exist in a vacuum, and therefore we also wrote and discussed in this concept of how our ideas are born and inspired by other projects. In a text called "There is no Patient Zero," written together with Gonzalo Bayo and Jordi Vivaldi. And projects that are very inspiring for us in the creation of the Magic Queen were, for instance, Goldberg and Santa Romana's project, the Telegarden, which was one of the earliest visions of a robotic gardener. Or Kodak, which discusses the relationship between humans, machines, and rituals to create a sound environment that accompanies a performance and links all the actors of a scene. Nygaard's project, Not Red But Green, articulates a grass sculpture installation, where Nygaard searches for the poetic potentials in the potentially destructive. And with our projects, we very much aim for an emotional feeling that visitors have when they are confronted with our architecture and when they're confronted with their own intuitive and physical response to the experience of entering a space where everything feels, where everything is wrong, but everything feels right. So things feel familiar to you, but they are actually not familiar. Materials that feel familiar are actually something else. The Magic Queen is actually the third iteration of the Artificial Ecologies series, whereas the first one was Bahoe Hohe Beauty in 2018. Second one was Terrestrial Reef in 2019, and resulting in the biggest soil 3D printed installation in 2021. And we also would like to show you a bit of the first two projects, just to start to also show you how ideas evolved throughout multiple iterations, and how we use actually installations to develop research and to push the research further.
To that, of course, I mean the whole idea of artificial ecologies and the whole idea of creating this sort of techno-organic gardens, no, where nature, technology, but as well digital fabrication are woven into one another, comes with a very first question, no? So how can we, for example, develop a new fabrication strategies for you know, linked to soil, no? And specifically, we were very interested into soil because of course it's a very abundant material, has a long history of course ancient techniques related perhaps to adobe construction, and so we were interested to understand how can we really first understand materials as a sort of substrates for architecture. And as well, how can we enhance this idea, the domain of low-grade organic materials in architecture? Yeah. So, and this is basically, this is how we started. We started, of course, I mean, like Daniela mentioned, these kind of projects, they require a very long time of experimentation, a lot of step backs, and as you see, like all the first prototypes were at a very different resolution, no? So it was more intuitively an approach towards materiality, which was basically, you know, coming from the fact, how can we harden soil? How can we compact soil? And how can soil stays compacted, no? And for that, we arrived actually to develop a methodology actually to approach organic materials. A methodology that is that has three different approaches, no? On a mechanical level, on a physical level, and on a chemical level. And those exploratory experiments indicated, for example, that you know, the compaction of the soil is a very key factor to understand, you know, to make soil structure, but as well the particle size of the soil, and let's say the time that and let's say the binders or somehow all the compounds that we need to use to make this material let's say stronger. But as well, it was a very interesting reflection for us on generally digital fabrication and materials in digital fabrication. You know, a lot of additive manufacturing processes, they are very declarative in the way how they present materiality. No, we know exactly how a 3D printed component is it's made because it looks like in a very specific way. No, so with the soil 3D printing, we really wanted to avoid this kind of being so declarative, but rather present a material that you see for the first time. No, so it's a kind of material that you don't understand really what it is. You know where it comes from. So,
and maybe one important thing to add is, what was very important for the project was to actually, a lot of research went into the development of the binders, because the binders, for us, was very important to have a biodegradable process, especially using a material such as soil. Because if you use a material such as soil and then you use a binder which is not biodegradable, you contradict your whole idea of why you should use such a great material that allows you to be a substrate, allows to grow, and allows to be biodegradable. Therefore, a lot of it went actually into the research of different biological binders, and also of course, on how to fabricate it. The first steps of the soil 3D printing were actually done with manual models, but then we moved on to robotic fabrication. And to work with a material such as soil is not as straightforward, as Tiziano explained, as it is an organic material and a granular material. As you can see here, the aim was to use 3D printing technologies, coming of course with digital models, and to use robots to compress the soil and to actually distribute the binder. As you can see here, that's the compression step. Here you can see this is the binder that we were working with that was completely sustainable and biodegradable. You can see here the tool, so that the tool that is carried by the robot is a custom-built tool, which is extruding the binder selectively at specific locations. It's a binder jetting process. And after the process of depositing the binder, a new layer of soil is added, and then the process is switched to actually compressing the soil. And by doing this layer by layer, we actually achieve a very precise 3D object inside the soil that is bound together.
I mean, after basically the modules are completed and printed, basically there is this phase which we found it very interesting, which is the excavation part, right? So humans or human agents are actually almost excavating what the robot did in a way, and revealing the structure through a sort of archaeological process. Yeah. Yeah, so those are basically the two other projects that somehow accompany the Artificial Ecologies series. No? And both projects, they have very different backgrounds in a way. Like on the left, for example, the Bio Beauty, and on the right side, the terrestrial reef. So the Bio Beauty comes as it was exhibited together with the University of Innsbruck. It was exhibited at the Ars Electronica in 2018. And the idea was exactly to actually anticipate a little bit a quarantine environment, an environment where nature is contaminated and where humans are not allowed to step in. While on the right side, terrestrial reef is a techno-organic garden again, and it deals with a completely different, let's say, entanglements. No, in this case between mushrooms and soil.
So Bio Beauty that you can see here, as Tiziano introduced it already, was exhibited at the Ars Electronica, and it was actually the first piece that started to deal with a lot of these questions. And it was understood as a chimera of both these natural and man-made materials with a techno-organic aesthetics. And this one here, just to compare it, was around 40 tons of soil with 14 individual soil 3D printed pieces. And it had a lot of ideas that we then again re-examined in the Magic Queen, where we say there was a performative aspect where visitors were actually invited to experience the structure with by having a guidance through it, and also this idea of equipping the robot with technological eyes, so cameras that actually re-examine the structure. So the idea is that the robot is not just actually producing the structure, but actually also inhabiting it and examining it and by examining it, start to develop an ecology of the sound environment of the robot that is actually producing the sound environment, and the material that changes over time. As it is a biomaterial, you see the structure is actually changing over time. It's cracking over time.
Slightly different is the terrestrial reef project, no? When in this case we showcase an approach that comes from the coordination between biotechnology and the term, for example, natural, living, what is synthetic, what is artificial. So there is a sort of harmony in a way to discuss these technologies. Specifically, the project focuses on two different types of fabrication, which is the idea of merging in situ and in vitro technologies. So whatever in vitro technologies were used, for example, to grow in lab a very specific strain of mushroom. And then this strain was transplanted into this in situ condition of this fabricated structure. No? So this duality and this as well ambivalence between what is done in the lab and what is done on site. This is something that was characterizing a little bit this project. No? And again, here we see the result of the cultivation process that was carried out in the lab. Yeah.
So all this introduction actually then leads to the Magic Queen, and now also to to kind of explain how we arrived at the point where we are now, also with technology kind of solid 3D printing and the theoretical concepts that come with it. Magic Queen is a performative, we understand it as a performative living architecture. That means living architecture because the soil itself is a substrate that can house living species. It is a 3D printed earth landscape, and it is maintained by a robotic arm for the next 6 months. And the structure was completely built on site by humans and machines within 3 months. It was important that only soil from the region and biomaterials were used, so the installation is therefore completely biodegradable. So that means at the end of the Biennale, the soil goes back where it came from. Various plants and types of fungi grow on the installation currently and throughout the exhibition. Whereas the robotic arm that is hung upside down has the job as or the function of the gardener. These are the first sets of the how we started to build it up. As you can see here, this is the Arsenale, and if you ever been in Venice at the Biennale, or if you might go, it's a very big structure, a very big building. And we just came with the robots, two different size ABB robots, and the soil came directly from the area around Venice. What you can see here is actually our fabrication setup. So this was what we were doing for 3 months with two different sizes of robots. The big robot to do the bigger scale prototypes and or elements, and the smaller one to do the small ones. A lot of the parts of the Magic Queen we're aiming to actually start to produce something bigger, to actually create an environment that you can immerse yourself in. So as you can see here, we really worked very hard to speed up the process and to actually create something in 3 months on site that would be without robots, for instance, not possible. Or
I mean, with the project, we really wanted to start to be confronted with a different scale, no? So until now, basically everything on the two gardens developed, they had a very, manageable scale, also in terms of, constraints for example, related to transport, no? So the idea of course, building up, on site for 3 months was of course a huge challenge, no? And that, of course, not only concerned the fabrication part, but also for example, the positioning and as well like in this case, a very specific technique for excavating all the soil 3D printed modules, no?
So as we showed before, after printing, we had to let it dry. So they had to let the binder dry and then excavate it. Then one of the robots that we used actually for printing became then the function of the robotic gardener. And here you can see, as it's culturally protected building, it was also not that easy to create a structure that is holding the robot in space upside down, to access as many areas as possible of the structure, to water it, to observe it. After excavating all the elements, as you can see here, they were placed or moved in place, and another layer of binder was actually placed on top of it. Here you can see we still did some small excavations when they were placed in the final position. Here you can see the top view of actually all the elements, and also our neighboring exhibition starting to build up. One really has to say, I think we lived there for 3 months, and it became kind of a bit of a home while starting to build up the Magic Queen. You see here, Philip Beasley is the structure behind us, which also was quite interesting to have bigger immersive installations surrounding us. Here are some shots of the final installment.
So, like we said, I mean, of course, the project had a very complex fabrication setup. No? It comprehended basically, I mean, of course, the fabrication, but as well a very rigorous way of designing, and as well of designing these 51 elements, and as well of optimizing each one of those. So as I said, there are 51 elements spanning from basically 300 millimeters to 2,300 millimeters, and with a weight, of course, that if you consider that 1 cubic meter of soil, it's basically around 1 ton. So you can immediately, roughly estimate, I mean, what is the weight we are talking about. And of course, as you can imagine, there was a lot of process that probably we would need to dedicate an entire lecture with, about how to optimize, for example, the center of mass, or the eccentric load of each component, because of course our goal was to create a soil structure that had a, let's say, complex enough geometry to allow us to as well drive some design ambitions, quite interesting design ambition, I have to say. And of course, like Daniela mentioned, no?
Yeah, I mean, what's very interesting in using biomaterials is this idea of being able to create a chronotopic architecture. That means an architecture that actually underlines the close relationship between time, space, and actors. So something that is hyper-local and hyper-temporal. Venice has a very specific climate, for instance. So we had to deal very differently with how we dry the elements, and how we place it and adjust our fabrication method. And you can also see in the cracking, so the cracking of the surface was intentional. And we very much like this process, because it's something where you can just apply a binder, but you don't know how it will crack. So you start to give some agency to the material and the process. And it's a unique piece that is only possible to stay there because of its location, the persons and the machines that were building it, and the time it was constructed in.
Of course, like we mentioned, I mean, the whole idea as well was to somehow highlight the passage from considering materials as inerts, which are barely, dead, to materials that are conceived as a substrate, no? Materials that can enhance can enhance life, or can be as a nourishment or a medium to enable something else. And so the soil structure, like we mentioned, I mean, the structure is composed of different components spanning from different media. There is an audio and a generative piece that is linked to the presence of the robot. The robot is understood as a gardener that is hovering the structure, will hover the structure along these 6 months, and will gather psychochemical data around the structure.
And the end effector that is mounted, that you can see here on the robotic arm, is constituted by 2 primary sensing cameras and devices and a processor. And the computing unit will then use the different machine vision artificial intelligence algorithms that we developed, and these ones gather and sort data to identify patterns deriving from the interaction of the landscape with the surrounding environment. The computer vision system is based on a combination of deep learning-based systems for object detection to perform the detection and tracking of people, and additional traditional computer vision techniques to detect grass, mushrooms, and surface features of soil organic landscape. We use a combined depth and RGB camera and an additional tracking camera that runs a simultaneous localization and mapping algorithm and provides positional, orientational, and inertial data. The system runs entirely on a single board computer that is placed also on the front of the robot, and it sends data over a network to other machines that perform visualization and sonification. So you can actually hear here in the background the sound that comes through all these algorithms and through this image analysis. This complete sound environment was further processed based on the data from the computer vision system. For us, it was very important that it creates a close amalgamation between all actors of the structure. So as you can see here on the left now, how it is detecting people, and the sound is actually adjusting to how many people are detected and what the robot sees. The robot is not just equipped with this machine vision, it's also equipped with a watering system, irrigation system, that is allowing the robot to care, as Tiziano said, for the plants and mushrooms that are starting to grow on the Magic Queen.
Here we have some impressions of basically the soil, the placement of the soil, and somehow that was the first, I think, the first week when basically there is a shrinkage of all the structure due to the temperature, humidity in the Arsenale, and for us, I mean, this shrinkage of these material properties is what allow us to, demystify as well how do we perceive soil as in this case as a construction material.
Another important factor for us was actually to avoid caging the robot. So this was something we were fighting a lot for, because it was very important to use systems that allow humans to be nearby robots without actually caging it, because in caging a robot transports a very different notion of robotics. So what you can see here actually in the blue light is a laser system that is actually creating a cage around, a light cage around the robot. That means when humans are interfering, it stops the robot. By that, we were able to actually avoid glass cage or anything related to that, and allow people to go as close as possible to the whole structure.
As you can imagine, the project was really developed within a large environment of collaborators that we really thank for all their work and their presence in Venice. And it was a very complicated project, of course, because it was developed in this dramatic situation that we all lived in the last year or more. And those collaborations are coming from a very different fields, like you say, some from music to computer science to robotics to as well microbiology. And so this is a little bit the context of where we developed this. Yeah.
And here is just some some final shots of the structure. I mean, what is very important is the structure is changing. Of course, these are shots that we took when the Biennale opened. But the whole idea is that the structure itself will start to change over time, and the more you visit it, you will always meet a different creature and a different situation. Of course, it's also important how it was sponsored, as it is a research project that is developed actually within our office. So thanks a lot. That's our website if you want to visit us, see a bit about our other works that are tangential, I would say. And yeah, we're very happy to actually show a bit of the background of the Magic Queen. And I hope some of you make it to Venice, stop by, share a picture, keep us updated.
Thank you very much, Daniela and Tiziano. That's a fascinating lecture. I have plenty of questions on my side, but maybe I'll let Mons fire.
Would you? Okay, great, absolutely. Thank you for that presentation, Tiziano and Daniela. That was very, very exciting to see the behind the scenes of how things actually worked, and the genealogy as well as the evolution of the projects coming from, you know, the early types of DNA strands and bacterial analysis that you did to finalize what it was. Throughout the lecture series, we've actually been talking about this idea of affordances, bioculturalism, multi-species, and climate change. And I felt like this project, in a way, is a perfect object to actually talk about that type of stuff. But I guess one of the questions for me is that
Mon, you break out over there. We missed the last sentences. Yeah.
Oh, can you? Okay, sorry.
Yeah, you're back now.
Okay, perfect. Affordances, bioculturalism, multi-species, and climate change. And I guess one of my questions that I want to ask is that within this project that you have, where do you see it going next? You know, this is a very sort of particular, you know, installation environment that you've controlled very, surely it's almost like a domestication of nature. I don't know if you've read The Hidden Life of Trees by Peter Wallenburn. He talks about the wilderness of nature is gone, that, you know, trees don't communicate anymore because we've domesticated them. And we've also killed this idea of nature off because we've sort of had agricultural processes. And what you've birthed is almost like a Frankenstein of nature, even the way that the form of it, how it looks, and the way that you've positioned it, the angles that you show it, almost feels like it's a sci-fi movie. So for me, the question is, where is it to next? Is it this strange creature that we're trying to engage with that has a life of its own and then can only be monitored by a robot, which I also find very fascinating because the robot has a life of its own, and the way that you showed it should actually be a short film talking about its sort of life within the Venice Biennale, and the way that it reads, it was reading dogs, you know, and different articles within the actual landscape, but nothing was actually present. So my question firstly would be, where to next? That this is the point where you have shared on a platform where people will see it.
I mean, yeah, this is maybe I start quickly. I mean, this is a very interesting question, which is a question that we ask ourselves in the office every day. I mean, right now, for example, we have a permanent project that it's our probably first permanent project, and where we were trying to actually define exactly how all those technologies, all this discourse can come together more as on a long term, you know, more on a long term, let's say, scenario, no? Because everything we see here, or everything you saw as well in our lecture, you have to understand that it's related to a very specific time frame, no? So a temporality that is very defined in a way. So, so of course, to your question, I think the next step would be to understand a larger temporality in terms of, or to really understand the scale of architecture, not in terms of age, in terms of aging, you know, process of how those processes can really, you know, can really change over time. And of course, doesn't need to look like that. I mean, this of course is it was our as well, you know, drive to, you know, to depict a very different scenario of architecture, you know, something that is a little bit different than you know, what you expect, you know. What do you think?
I know. I think the next step would be, you know, we saw how we slowly increase in size. I think that's something that we're really working on. I think it would be great to start to actually go into, you know, building scale, because then you start to have a lot of different. Every time you jump scale, you start to, you know, encounter a lot of very different battles and a lot of different challenges. And I think, I mean, the thing with the time spent. Even now, the 6 months of the Biennale, it was the first time we have, as it is an interactive installation, to have, and everyone who ever did an interactive installation knows 6 months working interactive installation is already a challenge. A more time interactive. So I think a lot of these things is we are developing them while going bigger and while going for longer placements. And I think that is actually quite interesting as a practice to use these chances to push the research further. So that every time you get the chance to exhibit. So that's also why we never exhibit the same thing. We always try to use every chance to actually push this research further and to show, you know, to show it morphing from one exhibition to the next one. And I mean, we got a lot of questions if we can exhibit the same thing. Can we not just bring it over? And you always said, no, that's not the concept. That's, you know, the soil stays there. We come with the robot and we need some time.
Maybe I can just jump on in terms of the questions of the temporality. How far, given that most of your work that you've shown today is always have this, as Tiziano already talked about, this notion of time associated with it. And yet our association of architecture has always been hypostatic. And, you know, even you were just trying to describe the aspiration to build something more permanent. And the idea is that, in fact, I'll rather call it kind of the proposition that you have put forward in your lectures is already, as you call it, kind of the techno-organisms, right? That in how far some of them are already alive as soon as it's been built, as soon as it's been constructed. I guess the notion of temporality of time perhaps needs to be adjusted in architectural terms when we discuss your work, you know, in sort of a certain degree. So I'm wondering whether perhaps this notion of time frames and staticness doesn't really quite yet, or maybe doesn't actually apply to you, but actually the notion that things grow for as soon as it's been built kind of apply more so in your work than others. In that sense, it is an organism. As such, what's your thought on that?
I think it's a bit the embrace of complexity. You know, that's the kind of thing. The moment you start to work with organisms or kind of living systems, or try to create something that has dependencies, you have to start to embrace complexities in your system, and not just, you know, metaphorical complexities, but actual complexities of systems that depend on each other. And at the same time, when complexities come, you have to face the giving up of complete control. So you need to create a framework that allows you to allow systems to develop while they still have a range of freedom within this framework you're developing. And that's, I think, where the complexity comes from. So you have a vision of geometry, but you don't exactly know. You have this kind of blurry zone where the structure, where your architecture can move within it. And I think that's a lot of the struggles, or also the interest where it comes from, where you have to, you know, you have to give up on this urge of control it and say, you know, it might grow, but it also might not grow. So even this idea that, you know, the magic queen could not grow, to give this up, that you allow this to happen, it's something I think which is very interesting psychologically. But it's a good task, because you start to really design more the frameworks in the system that provide other systems to grow or live within it.
I mean, for me, going to your question, Paul, I think it's a very serious, actually, very serious topic, no? Because somehow we really need to I have the feeling we really need to renegotiate our expectations towards the built environment, and the temporality of it. Like a lot of these materials, a lot of organic materials, for example, are completely discarded currently from new fabrication, digital, robotic, or techniques, or as well in construction, because they are not, for example, rigid enough. They're not strong enough. And so, of course, the easy way out is to use, as you probably know, a palette of material that is quite conventional, no? And but we rather believe that we should really mitigate this first our expectations towards those materials, to really accept potentially that a building or a material has a very precise lifespan, and to not go the easy way out. So to not go to really, to researchers as well that pay off in a very, very short term, but to really go on speculation and research that they have such a longer time span, a longer term of development. Totally.
No, I think that's, yeah, go on.
Yeah. No, it just came to my mind. We had this very interesting experience. A visitor came and she touched the structure. And then she said, oh, it's bouncing. That's interesting, because it completely feels different than what we feel like we know when we touch normal walls or ceilings, where we don't feel like, because for instance with soil, you have this allowance to actually, a flexibility in pressing. And it was very interesting how people start to react very differently, because we are not used to have a lot of different sensual experiences when we talk about architecture. It's, it feels the same. You touch a wall, it doesn't move. This one, it moves if you need to start to negotiate it. And I think this is also questioning a bit the role of architecture, like what, and I mean, soil is a building material, so that's another thing. It's something that is actually used. It's just in our Western context, not that common anymore, because all building regulations and all these things came and pushed for a more regulated construction.
I want to ask you about questions around notions of agencies that you talked quite a fair bit about in your work, the actress, as you call them, which I thought is interesting, and also these notions of organic in your work. First of all, I guess the organic here is seemingly artificial, as I think Mon was alluding to earlier, but at the same time, naturalistic in its material characteristics, but beyond that is completely synthetic, so, and I wonder, I mean, obviously the agencies that we were talking about, both robotics, visionings, fabrications, humans, for example, etc., and also through your teaching, I know that you guys did a lot of work also with robotics and human interaction, and visioning last year you were doing in the A visiting school. Talk to us a little bit more about your, I guess, notions of, or views around this notion of artificialities and nature, because this, I mean, as Mon kind of mentioned, we did have the discussions already about naturalism, but I think these are quite interesting, and potentially also what your territories are slightly also different. Would you maybe give us
shortly? Yeah, of course. I mean, there is of course a very interesting debate that for us is quite it's very dear to us, which of course this whole debate about nature culture and where is this coming from and what are those perspectives around it, and of course we really much in line perhaps with the vision of Michel Serres and this notion of natural contract, of of the need somehow to reestablish this kind of a contract in how we humans understand form of negotiation, towards nature, But the interesting vision, I think, that we find in him is that his idea of nature. It's an idea of nature that needs to evolve with in a very specific technological time frame, and also a very specific technological context. So it's never really the nature, like a modern nature idea of untouched and somehow chested nature. It's always a kind of a nature that is a concept of nature that is completely renegotiated within a very technological context. So in a way, we accept that there is a sort of artificiality, or there is the notion of synthetic in our in our understanding of nature. Yeah.
And I think because a lot of our projects we work very closely with scientists, and then you start to give up very, very fast this romantic idea of what's natural, what's artificial. Because if you start to talk with them about microbiology, or if you start to talk about synthetic biology, if you start to talk about the idea of gut bacteria and how long cyanobacteria they are, you start to really rediscuss what it means. And then at the same time, we have all these new machines that are actually restructuring, and they're already integrated in nature. And I mean, we mentioned it shortly, this idea of creating some autonomous wilderness, a new wilderness that is created through technologies. It's very, very interesting and dear to us, because there is no difference for us in a machine and a biological system. The idea is actually to bring these systems closer to each other, and actually we can enable them to create something new, something autonomous that might not need, as a long vision. Now it still needs us, but might not need us in the long run. And this can happen on different levels. So this can happen on the machinic level, can happen on a synthetic biology level. But I think it's it's all kind of very much linked, and this kind of linkage that could create this new nature. But first we have to destruct the idea of nature that we have. And I think that's something very important, where you say, is that really nature? I mean, living in the Alps, European Alps, where everyone thinks that's the ideal nature, and then you discover it's actually, partially war machine and partially a tourism engine. You start to really, you have forced to rediscuss these kind of ideas of nature.
I think one of the things that I also realized is that the project itself tries to mimic nature in its sort of forms and the parameters. Could you talk a little bit about how the way it looks and the way it's constructed and the way that it's this sort of alien landed in the middle of Venice Biennale came up with this idea of such a laborious process to make it look like that? Whereas people might sort of get confused with that, just you took it from the Amazon jungle and put it there. And I think maybe let's talk a little bit about form, because I'm curious, I think we all appreciate the bacterial, micro, new forms of materials, things that are coming out. And, when we invented concrete, but now we can 3D print soil, let's say. Why did this form come to mind, and why is this the way you wanted to show it?
Well, I mean, there are a couple of course, there is a very, let's say, very personal answer to this, which is about we don't like boxes, or we have a very different, taste in terms of architecture, or what architecture might.
I think a question would also be like, the question will also be like Louis Kahn from a brick, right? The brick wants to be an arch. I was just alluding a little bit if the soil actually wants to be this shape in a way.
Soil is, I mean, that's a beauty. So if one prototype doesn't have a geometry that soil can handle. That means it's very clear, so you have a center of mass, you have a specific overhang that the binder can hold. So all these kind of things came into the design. Because you can actually not repair. If a piece breaks because it's the wrong geometry, you cannot repair it with the binder system. So it's very straightforward. Either works, it doesn't.
We haven't shown you. The cemetery of the project.
I find this super interesting because the time sequences we're talking about time again is that the material reacts and responds in a very different way, right? That shrinkage system that you're showing, the way that it's like drying out and starting to peel, those are the things that I felt are the most interesting, right? Because that is a sort of unique performance of that material. And it's almost like the same question that Paul always asks, is like Cedric Price's sort of question is like, technology is the answer, but what's the question? It's almost like you have this material now. What is the question? Where should it be? Where should it live? Where could be the best placed? And also in any of our careers as well, it's this chicken and egg situation. I always find it's we're trying to solve a problem or we're doing experimentation. And sometimes we do all this crazy experimentation where I sort of draw this Venn diagram of the amount of time spent, the idea I have no idea what I'm doing, and luck, right? And it's like that sort of middle area where we hit sometimes when we do this research, because the whole point of innovation and research is to find the unknown or the unexpected. And I feel as though once we come out with all these projects, it's like, where would this project be? Let's find a place for this, maybe not to be in a building that we currently understand, but also maybe a place where we haven't really designed or programmed yet.
Yeah. I mean, we talk a lot about the design decisions and how important it is that you think about the form and which message you bring with it. And we were always very interested that people don't immediately understand how it was fabricated. So that when you look at it, you don't, you recognize forms that might seem natural, but you don't understand what is the material immediately, and you don't immediately understand how it was fabricated. So for instance, that was the reason why we didn't like when you normally 3D print, when you see the layering of the 3D printing, you immediately understand how it was created. We were very much interested in that you can just encounter it with and then slowly discover and question how it was created. And also the idea of the cracking that we apply, like the binder that we apply extra, that allows it to break open was something was similar to that. So we said people were very confused. They thought it was concrete. And then they asked us why we colored the concrete brown. Till we told them it's soil, and then they were confused because we had different soil on the floor. And I said, but then what's the other thing? And I was also soil, and then they pointed to the concrete and said, and this one is then soil and white. And we said, no, that's actually concrete. And this is actually quite interesting because, people start to get very, this idea of they encounter something familiar, then you tell them, no, they're actually completely wrong about it. And then they start to re-question everything in the same process. And you can do this with geometry or with how you place it. And I mean, these arms that we have at the Magic Queen, it was for us a way to, that you start to can be immersed in it. And I think a lot of this was really to, to make it as immersive as possible.
So people can't go in it. People can't go in it. Okay.
So originally we did, but out of security reasons, we had to extend a bit because people like to touch robots. I don't know why. So out of this, but as a concept, I mean, it was planned that you can go as far as possible in.
Sorry, Tiziano, I cut you off.
No, I mean, it's also it's really, I mean, I don't know. I think we have the feeling that to maybe culturally defamiliarize a little bit, us with the conventional idea of architecture, as well of inhabitation. Somehow, we really saw as well in the Biennale during the first days that that people have a very conventional idea of architecture generally. very conventional. So it was interesting actually to explain the project to the public as well, because somehow I think there is an opportunity of absolutely. I mean, the design and the way, let's say, the branch of design that we all come from, digital design, it's also an opportunity to really rediscuss culturally what does it mean, what does it mean to make architecture today. And very, very important. Yes, sure.
Maybe before we wrap up, I just have one question around the work currently. So the last few projects, certainly Magic Queen and the one before, is almost presented in the art architecture forums, and one that's also then presented at Chelsea Flower Shows. So the interactions with, is kind of fully into the foreground, this sort of new techniques in 3D printing soil to a different audience, but also bringing the collaborative efforts to a different audience. I mean, you already talk about the feedback from the publics and how they react to strangeness. And in a sense, to me, I mean, I think that is what you're doing are already extremely architectural to that strangeness. I'm wondering, I mean, looking back to some of earlier questions of Mont in terms of what's next, and the other day, Christina Vavia already talked about how one should present research in multiple forums, and both of you are also researchers and PhD candidates, etc. I'm wondering, in terms of kind of coming back to this notion of design research and presentations of it and how one will actually perceive architecture, not simply as built, but also as a form of life research. In your instance, it's very much a life research, literally, quite literally, and I thought that was super interesting. How would you start to negotiate the two in terms of kind of the presentation, not to just to the audience, but also in terms of dealing with design research as a form of practice?
Yeah, I mean, that's a very interesting question, I have to say. It's difficult. It requires a lot of energy. We have a lot of ideas that are born within a very different context, because at the end we are operating in a lot of museum or in the media art world. So very different context, very different audience, very different condition of developing projects, I have to say. Very different temporality as well. So this is what I was saying before. So what we are trying to, right now is to really transfer this, all these bits and pieces that we are developing into a scale or into a context that is more familiar to architecture and to our understanding of architecture, but also to a shared understanding of architecture in terms of temporality, I have to say, not just in terms of scale. And so the case of the flower show was a very interesting one, because I think we realized in London and UK that culturally people are very, they're not surprised about technology. So they were extremely used to see robots, for example. So to see a robot in a garden or to see the robot as a gardener was something that was not at all a surprise. And which was the opposite in Italy. So there is a kind of course, we look at these events and places and audiences with extremely interest to understand, how do you present those ideas, to a broader public. So I don't know if it makes sense.
Yeah, maybe just to add, I mean, what's really interesting actually, and we do this quite a bit also in the practice, is to lend technologies from other fields. So that means technologies or techniques that are used or already very developed in other fields, and we try to, you know, we look at them and we start to look at them from a different angle than a scientist, for instance. And that's quite interesting, because you start to, everything we do is spatial, even if it's, you know, if it's a small device that is about translating a bat signal to something visual, it's immediately linked to a spatial question. And this one is something very unique also as architects that we bring with it. So even if we are working within an art or an art and science field, you really start to see the unique qualities that you bring as an architect to an environment such as this. Because everything that you're working on still brings the question of spatiality with it. And that's something that is, especially with us, when it comes to the question of performativity, or we are not interested in the object by itself, but actually how it arranges, how we move through the space. And at the same time, we always see it very seriously as architecture and how it can become a building. So this always comes with it. So even if it's very, you know, a very technical exhibition, in our head, it's already implemented in an architectural building, for instance. It's already, we already envision how it's, for us, it's not a big jump. It's just different scales of operation that need to be done to start to actually implement these technologies and innovations in a bigger building scale.
We got one more questions coming up from our chat from the MSDX side. So this is a question from Alex Felsen, who's our new chair, Elizabeth Murdoch's chair in landscape architecture. So the question is, the work that you created for the Venice Biennale appeared to be an early exploration of the interface of technology, robotics, and biological material, soil. How in depth do you need to understand the living materials that you're working with? You mentioned particle size. Did you also study texture, structure, porosity, bulk density, color, temperature, aeration status, and water relations? Did you work with soil ecologists? And when you source your soil, did you explore options for the kind of soil you use for the exhibit?
Yes, all of this. And it was a very long research. It was 2 years of research. It's still a research that is continuously evolving, no? And of course we had a close collaboration with the soil experts from a microbiology perspective, but as well from a mechanical perspective of soil in terms of composition. So the soil we use in Venice is it's a soil that in terms of composition is tuned to the robotic fabrication process that we developed in terms of you know, for example, if the just an example, if the hydraulic conductivity of the soil is not at a very specific level, there is no, the soil cannot bind, basically, because the soil is a very I don't know if you ever tried to put water to spill a drop of water into soil. So if the soil is very dry, this water stays on the surface. No? So imagine if you work with, and we work with hydrogels. So hydrogels, they're highly viscous, so they will not, you know, they will not go through the soil. So there is a huge research on understanding particle size, hydraulic conductivity of the soil, and how those parameters are really linked to a process of fabrication, robotic fabrication. That is also the shrinkage. Like shrinkage is a very shrinkage relates to how compact is the soil. So if you don't press the soil enough, the soil will shrink more, basically. And this is, of course, by planning a very huge installation where all the pieces and units, they need to be leveled and exactly at the same height at some point. That could create a huge, huge compromises. I don't know.
Yeah. We had all this testing phase with the layer height, different samples of soil, we had to send some soil back because there had too many stones inside. So we can't use soil that has a lot of, small rocks or anything like this. So that's why we have this additional 2 years of preparation phase to actually tune all these factors.
That's amazing. And maybe on that note, it is 7:30. And I just wanted to say such a privilege and honor to hear you both speak about your practice and all the things that you've done in relation to what the sort of new paper is about new ways of practicing, new ways of architecture, looking at different types of sites, from forensic architecture that we had 2 days ago, looking at political and social change, to Stefan and Pablo last night, to looking at multi-species, climate change, as well as different ways of practicing through mapping, and also yours sort of through bacterial research and material research in a way of how do we actually create materials to look at different ways of our built environment, and not only looking at robotics and I guess nature as separate things, but as like similar entities. I think the students could definitely take a lot from this, and just thank you.
Thank you, Daniela and Tiziano. I mean, really, as you know, your interests and my interests are very much aligned. Super enjoyed this lecture. Thank you very much. And so on that note, I'm going to just quickly share my screen in terms of upcoming events. So to follow on Daniela and Tiziano's lectures, next Monday, we have Stellar, which will continue this tendency of technologies. He's going to talk about embodiments, aliveness, and agency, zombies, cyborg, and chimeras. Following that, we will have Adolfo de Valera and Oscar Johanssens on unnatural disaster. And to wrap up our lecture series for the AA Visiting School Melbourne, next Wednesday, the 14th of July, we will close with a public lecture by Emmanuel Cole on AI sampling, plasticity, and core. So until then, join us on Monday on campus or online for the Stellar lecture. Good night.